Good morning, students. Welcome back once more to mathematics classes. Last class we had seen the quadratic equations and the related terms of quadratic equation, that means factorization, then formula method, then nature of roots of the quadratic equation as well as word problems. Hope you all have completed the homeworks as well, because already almost all of you have received the textbooks, and now you can go through the different types of questions given in the textbook as well as in the exercises. So I think you are familiar with this all. Today we are going to see one more important term of your unit, that is factorization. Factorization of polynomials. Factorization of polynomials. We had seen factorization by taking out the general term, common term, then grouping and factorizing, then factorization of a square minus b square, then factorization of a trinomial, as well as factorization of cubes, a cube minus b cube and a cube plus b cube. We are going to deal with the factorization of one of the another term, that means factorization of polynomials. Factorization of polynomials. I think you are familiar with the polynomials. Polynomials, it is familiar to you because you are dealing algebraic expressions since class 6th onwards, and 7th class you had seen polynomials. What do you mean by polynomials? Polynomials means an algebraic expression having different degrees. Degree can be 2, degree can be 3, degree can be 4, etc. Higher powers. So we were dealing with the linear equation having degree 1 only. Then we were dealing with the quadratic equations were having degree 2 only. Now here we are going to see the factorization of polynomials, means polynomials can be of any degree. That means we had already seen in 6th class, we have learned about this monomial, trinomial, binomial, etc. Monomial, binomial, trinomial, and these all are grouped, termed as polynomials, and rather than the power 3 comes, generally it is known as polynomial. So in general form, if you are writing the general form of a polynomial, you can denote as a0 x power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2, etc. That means where a0, a1, a2, etc. are some constants with one variable x or 1. Okay, for example, 2x cube minus 7x square plus 11x minus 8. Have you seen the degree? Degree is starting with 3. That is a0 x to the power n. Higher power. Then x minus 1. Degree 1 comes less. 7x square. Then again x minus n minus 2. That means 11x minus, there will be a constant term at the last. So this type of expressions are known as polynomials. Now today we are going to deal with the factorization of polynomials. Factorization, you know, we have to, instead of writing this expression we are making into the product form. We are making it into the product form. That means, as you have seen last class, quadratic equation, that is also a polynomial, but by factorization you are writing the quadratic equation in the factor form. For example, if you are having a number 12, you can write it in the product of factor form. That means 2 square into 3. 4 3s are 12. Or you can write it as 2 into 3. So this is the product form of a number. Similarly, this expression we can write it in the form or the form of a product form, right? Form of products. So that is known as factorization of polynomials, right? Now, generally, if you are having a polynomial, this polynomial you can denote it by a notation, that is f of x equal to 2x cube minus 7x square plus 11x minus 8. That means this polynomial indicated with the general term x. Variable is x. Or you can denote it with another. That means we are taking out any of the alphabets from the English alphabet. That means G of x or P of x or Q of x. These all are denoting the polynomials, general form of the polynomial, or the polynomial we can indicate, the given polynomial we can indicate as f of x equal to, or g of x equal to, or p of x equal to, or as well as q of x equal to. Any of the alphabets you can take from and you can denote it. Okay. So today we are going to deal with two of the most important theorems of a polynomial. If you are taking out a polynomial in general, f of x equal to x cube minus 7x square plus 14x minus 8. We have taken a general polynomial f of x equal to x cube minus 7x square plus 14x minus 8. I think in class 7 you have studied, check whether x minus 1 is a factor. X minus 1 is a factor of f of x. How will you check this one? We were dividing it with the long division method. That means you are dividing it x cube minus 7x square plus 14x minus 8. You are dividing this with x minus 1. X minus 1, and I think you are familiar with the division method of polynomials. This is also a familiar term to you. So you are writing the coefficient either on the top or on the right side. We need x cube. We are having x only. So we are multiplying it with the x square. So x square, that means x cube will come. X square into minus 1. Minus 1 x square. Now you are subtracting. It means this term will cancel. Right? And the next term, minus 7 minus minus plus, that means minus 6x square plus 14x. Now you need minus 6x square. Already you are having x here. So you will multiply it with the minus 6. We are getting minus 6x square plus 6x. Now subtracting, you are getting 8x minus 8. What is the number required again? You need plus 8. So you are taking out plus 8. So 8x minus 8 comes and the remainder is 0. So if the remainder comes as 0, what does it mean? X minus 1 divides the polynomial f of x completely. X minus 1 divides the polynomial f of x completely. You are getting the remainder 0. So we can say that x minus 1 is a factor of x minus 1 is a factor of f of x. Instead of this x minus 1, if you are taking out any other term, you can take the same as, instead of x minus 1, if you are dividing the polynomial with x plus 2, check once more, x plus 2, if you are taking x plus 2, we are going to divide the polynomial with x plus 2. That means x cube minus 7x square plus 14x minus 8. You are going to divide it with x plus 2. We are checking whether it is a factor or not. So you have to divide with multiply with x square, then only x cube will come. X cube minus 2 plus 2x square. So after subtraction you are getting minus 9x square. You need minus 9x minus 9x square minus 8 plus 14x here. So minus 18x will come. Minus 18x after subtracting, that means this will be also positive. So you are getting 32x minus 8. 32x minus 8 means next term you have to multiply it with will be plus 32. Plus 32, if you are multiplying, means you will get 32x plus 64. Plus 64 again, while taking out the remainder you are getting it as minus 72. Did you understand both the difference? First case we were getting the remainder as 0. When we were dividing the polynomial with x minus 1, we were getting the remainder as 0. But in the second case, again we were dividing the same polynomial with another term x plus 2. With another term x plus 2, you were getting a remainder. Remainder was minus 72. So you can understand the difference between these two cases. Clear? If any term, while dividing, if you are getting the remainder as 0, it implies that the given term is a factor of the polynomial. Means if factor means the remainder should be 0. Right? Or if you are not getting the remainder 0 means if any constant comes there means the given term is not a factor of the polynomial f of x. The given term is not a factor of the polynomial f of x. So that is the difference. So by using this example, please note down these two examples. One, we have the same polynomial. We are dividing it with x minus 1. Then the remainder comes as 0. And again we are dividing the same polynomial with x plus 2. You are getting the remainder as minus 72. Okay, please remember these two cases because I am going to explain one of the two theorems of this chapter. That's very important. While explaining the theorem, you will be understanding very easily if you understood these two terms. When we are getting 0, at what case we are getting the remainder 0 and at what case we are getting the remainder as a constant. Okay, so by using this two different examples with the same polynomial, I am going to explain the theorems. The first theorem, it is factor theorem of the polynomial. Factor theorem. As I have told you, these polynomials we get denoted by the general term f of x, g of x, q of x, p of x, etc. So, if a polynomial f of x is divided by x minus a. Did you understand? Here we were dividing it with x minus 1. If any polynomial f of x is divided by x minus a, and we can say that if x minus a is a factor, if and only if f of a equal to 0. I will show you how will you get this f of a. Okay? And this is factor theorem. Factor theorem means when we are taking out the value of x, as in the last class we had seen the zero product rule. Zero product rule means x minus a we are equating it into 0. That means x value will be equal to a. So if x value we are substituting it in the polynomial and you are getting the remainder 0, then we can say that f of a equal to 0 implies that x minus a is a factor of f of x. X minus a is a factor of f of x. This is factor theorem. And the second one is remainder theorem. Remainder theorem states that when f of x is divided by x minus a, then f of a is getting as a constant. That case x minus a is not a factor. X minus a leaves a remainder k. Both the theorems are given in your textbook. F of x divided by x minus alpha. Instead of a, they have mentioned here x minus alpha if and only if it is a factor. If and only if f of a equal to 0, and if it is not a factor, that case it will exist with a remainder, and that remainder will be f of a will be equal to k. The same example I will explain. The same example, that means without dividing the polynomial you can check whether it is a factor or not, because in the lower classes you are dividing and finding out the remainder, or you are dividing and finding out whether it is a factor or not. Here in this class we will see without actual division we can find out whether x minus 1 is a factor. As in the first case, x minus 1 is a factor. So, this is the polynomial given. F of x equal to x cube minus 7x square plus 14x minus 8. Okay. So, check whether x minus 1 is a factor. That's my question. Check whether x minus 1 is a factor. So, we are checking it by division method. Instead of that, here we have another method without division. Another method. That means x minus 1 is a factor. If and only if x minus 1 equal to 0 we are equating, you will get the value of x. Implies x equal to 1 you are getting. Are you remembering? Roots of the quadratic equation I have told you. Roots of the quadratic equation or solutions of the quadratic equation. While I was teaching there, I have told you we will equate it into zero product rule, and whatever the value comes for x, that will be the roots of the equation. Here also the same concept. X equal to 1, that will be the root of the, if it is a factor, then that will be the root of the polynomial. So how can you find out this polynomial? How can you find out whether it is a factor or not? We will substitute it in the polynomial. That means f of x is given. In the place of x, what you have to substitute? In the place of x, you have to substitute f of 1. So f of 1 value, f of 1 will be equal to 1 cube minus 7 into 1 square plus 14 into 1 minus 8. That is f of 1. Right? So you are getting 1 minus 7 plus 14 minus 8. 14 plus 1, 15. Minus 7 minus 8 minus 15. So you are getting the value equal to 0. Did you get it? Okay. So if it is a factor, while substituting the value of x in the polynomial, you will get the answer 0. That's what I have told you in the theorem. If x minus a is a factor of f of x, if and only if f of a will be equal to 0. If f of a, here the value of a, x minus a, here the value of a is, 1. And f of a, f of 1 answer you got as 0. So when you are substituting the value of x in the given polynomial, and if you are getting the answer as 0, then of course you can say it's not x plus 1. While substituting it here, it will be x minus 1. Then we can say that x minus 1 is a factor of f of x. The same concept you can take there. We have divided it with x plus 2. X plus 2 is a factor, means x plus 2 equal to 0, equating means x value will be getting as minus 2. Then you will substitute here f of minus 2. F of minus 2. That means minus 2 whole cube minus 7 into minus 2 square plus 14 into minus 2 minus 8. After simplification, what will you get? Minus 8 minus 28 minus 8. Right? So 28 minus 36 minus 36. What will you get? Minus 72. Did you get the same remainder? Minus 72. So instead of, this is a short method. You are happy without dividing. You can check whether it is a factor or whether it leaves some remainder. So in this case, There is a remainder leaving minus 72. So with these two examples, I think the factor theorem as well as remainder theorem, no need of studying it. Theorems will not ask in the examination, but you have to understand, because by using factor theorem or by using remainder theorem, solve or check whether it is a factor. So by using factor theorem means there will be the answer, the remainder will be 0. Then we can say that is a factor. If it does not give 0, if it is giving some constant value, then you can say that it is not a factor of f of x. So I think up to here it is clear. What do you mean by factor theorem? If x minus a, f of x is a polynomial, and when divided by this polynomial, f of x is divided by x minus a, if it is a factor, then it gives the value 0. If and only if f of a equal to 0. Then only we can say that x minus a is a factor of f of x. Clear? Instead of that, if x minus a leaves any remainder, any constant as k, any constant in general form we have taken it as k, that case x minus a is not a factor of f of x, and x minus a leaves the remainder k. Leaves the remainder k minus 72. So up to here, students, I think it's clear to you. Any doubt, any confusion, you can ask later only, because nowadays it's not possible. As you are dealing with the online classes, you can go through it. If you didn't understand, again and again you go through the same module, it will be clear to you. Okay, so we were dealing with the factorization of polynomials. As I have told you, quadratic equation is having degree 2. So quadratic equation was getting with the two factors. So according to the degree, the polynomials are having the number of factors. Here you can see the degree is 3. Degree is 3 means this polynomial f of x is having 3 factors. F of x is having 3 factors. Okay. And the application. So we had seen the factor theorem. Factor theorem implies that while substituting the value of x, if the answer comes as 0, then it will be a factor of f of x. Or when substituting the value of x, if we are getting any constant value, then it is not a factor, as well as that constant value will be the remainder. So without actual division, can you calculate the remainder? That is our actual division. So without actual division, can you calculate the remainder of the polynomial? Yes, you can calculate. How will you calculate? You will equate the given factor into 0. Then you will get the value for x, and that value of x you will substitute it in the equation. In the polynomial, you will substitute it in the polynomial. Wherever you are having x, there you will substitute the value of x, and then you will simplify. Whatever the value you are getting, that will be the remainder of the polynomial. Right? Or you can check whether x plus 1 is a factor, or x minus 1 is a factor, or x minus 2 is a factor. What to do? The same procedure. You will take out the value of x. If you are getting the value equal to 0, it implies that that term is a factor of f of x. That term is a factor of f of x. I think everything is clear to you. So without the actual division, you can calculate the constant value, the remainder value, as well as you can check whether it is a factor of f of x by substituting it in the given polynomial. Clear? So up to here it is clear. I think now we are going to see the applications of factor theorem as well as the remainder theorem. The applications we are going to see. Applications means we have to find out the value of some constants, if it leaves some reminders, or if it is a factor. How can you find out the actual value of k or something. Okay, that's what we are going to see. So factor theorem, remainder theorem, as well as polynomials and the polynomials factorization. This as I have told you, this polynomial is having 3 factors that I will show you after completing this concept. I will show you how to find out the 3 factors. Okay. Now, if you are having, as I have told you, we will denote the given question, given polynomial with any taking out any alphabets f of x or q of x or p of x. We will denote it. Then we will substitute the value of x. So without actual division, find the remainder. It is clear. Now find the remainder only given. Find the remainder for 3x cube. F of x is given as 3x cube plus 7x square minus 5x plus 1. What is the question? Find the remainder. Find the remainder when this polynomial is divided by 2x plus 1. When this polynomial is divided by 2x plus 1, find the remainder. So what to do? How will you find out the remainder? Check out. How will you find out the remainder? Check it. Okay. How will you find out? Yeah. 2x plus 1, you will equate it into 0. 2x plus 1 equal to 0 means what will you get? 2x plus 1 equal to 0 implies that you will get the value of x as minus 1 by 2. Are you getting x value as minus 1 by 2? Yes. Then what to do? Our question is find the remainder. So you will substitute f of x instead of f of x. What will you write? You will write it as f of minus 1 by 2. F of minus 1 by 2. That is equal to 3 into minus 1 by 2 cube plus 7 into minus 1 by 2 square minus 5 into minus 1 by 2 plus 1. Right? Yes. Then you will simplify it. That is 3 into minus 1 by 8 plus 7 into minus square will be positive. So 7 into 1 by 4 minus minus plus 5 by 2 plus 1. Now what to do? You have to take the LCM. That means LCM is 8. So minus 3 plus 7 into 2 plus 5 into 4 plus 8. 1 into 8. All divided by 8. Right? Then you will simplify it. Minus 3 plus 14 plus 20 plus 8 divided by 8. So you are getting the remainder as 28. 30 to 42 minus 3. So 39 by 8 you will get as the remainder. 39 by 8. So this is the concept of calculating the remainder. Without the actual division, find the remainder. Did you understand? Hope you got it. Without the actual division, find the remainder means you will equate the given term. It does not implies that this will be a factor. So we are going to check whether it is a factor. If remainder comes means it's not a factor. So in this question directly it is given find the remainder when this polynomial is divided by 2x plus 1. So you got the remainder as 39 by 8. It implies that it is not a factor. So this is the concept. Without the actual division, find the remainder when it is divided by the term. Okay. Now another question given here. Find the value of k. Find the value of k. If you are having the textbook, we are solving exercise questions. So find the value of k when 2x cube plus 3x square, 2x cube plus 3x square minus kx plus 5. Kx plus 5. This is the polynomial given. So the polynomial we will indicate as f of x. F of x is given as 2x cube plus 3x square minus kx plus 5. So find the value of k. So there will be an unknown quantity k given. So for that one more condition is given. When it is divided by x minus 2, leaves remainder 7. When it is divided by x minus 2, leaves the remainder 7. So that's the question given. Okay. So how will you find out the value of k? How can you find out the value of k? It is given that there is a polynomial f of x is equal to 2x cube plus 3x square minus kx plus 5. When it is divided by x minus 2, it leaves a remainder 7. That means when we are substituting the value of x, what will be the value of x substituting here? X minus 2 equal to 0 implies that x equal to 2. Yes. X equal to 2, once we are substituting here, we will get the remainder 7. X equal to 2, when we are substituting it in the polynomial, we will get the remainder 7. So LHS, RHS, both the sides we have the value. After simplifying, you will get the value of k. So according to question, how can you write? According to question, f of 2 will be f of 2, that is our remainder. F of 2 will be equal to 7. That's the question given. F of 2 equal to 7. Now, how can you find the value of k? That means 2 into 2 cube plus 3 into 2 square minus k into 2 plus 5 equal to 7. Right? So 8 2s are 16, 4 3s are 12, minus 2k plus 5 equal to 7. You will take out the constant terms. That means 28 plus 5, 33. 33 minus 2k equal to 7. What to do? Either you take minus 2k over there, or you will take the constant term over there. That means minus 2k equal to 7 minus 33. What is 7 minus 33? Minus 26. Minus 2k equal to minus 26 implies that k will be equal to 30. So this is one of the application of the remainder theorem. Remainder theorem's application. Application means when it is leaving the remainder, you will substitute the remainder value in the RHS side, and you are having the term given, the dividing term is given, x minus 2. So from that, you will take the value of x, and that value of x you will substitute it in the polynomial. Then after simplification, you will get the value of k. Just to note down, find the value of k. It is question number 4. Question number 4 of your exercise. Today we are dealing with exercise 6 because this chapter is 6th chapter. So we are dealing with exercise 6. Only one exercise is there. So 6th exercise, 4th question. This one. I think almost 80-90% of the students are having the textbooks now. So there won't be much problem. You can take your textbooks and keep in front of you. While I am dictating the questions, you can go through. Examples questions normally I am not solving. You can go through it. So exercise, few questions we will solve here as classwork that you have to note down. And after completing the session, I will give some homeworks. You will not get your homeworks on website. Daily homeworks, day to day, you have to complete. So with my classworks, my homeworks will be there. That day itself you have to cover the homeworks. So just to note down in your copy, this one, f of x. F of x equal to, what is given? 2x cube plus 3x square minus kx plus 5. That is question number 4 of your textbook. Exercise 6. Okay, chapter 6. This is chapter 6. So, exercise 6. Factorization, you got the value of k. Alright. Now, we are going to see exercise question number 7. When two polynomials are given there, two polynomials x cube minus px square plus x plus 6 and 2x cube minus x square minus p plus 3 into x minus 6. Both the polynomials leaves the same remainder. In both the cases, the polynomials leaves the same remainder when it is divided by x minus 3. So, find the value of p. That's the question. Find the value of p. Okay, what is the question given? Question number 7. When polynomials, so I am taking one of the polynomial as p of x. P of x is given that, what is p of x given? P of x is given as x square, x cube minus px square, x cube minus px square plus x plus 6, and you have one more polynomial, so the other polynomial you will take it as g of x. P of x we have taken, other polynomial you will take as g of x, 2x cube minus x square minus p plus 3 into x, then minus 6. When these two polynomials divided by x minus 3, these two terms we are going to divide it with x minus 3. Dividing it with x minus 3. In that case, both the cases, these polynomials leaves the same remainder. These two polynomials leaves the same remainder. What does it mean? That means whatever the value, whatever the remainder gives by p of 3. Because x minus 3 implies that x will be equal to 3. And when we are substituting p of 3, you will get a remainder. That remainder is equal to g of 3. P of 3 equal to g of 3. That's the question given. Did you understand? Both the polynomials leaves the same remainder. How will you calculate the remainder? We are calculating the remainder by substituting the value of x in the given polynomial, right? So, according to question, what you can write? According to question, you can write it as, according to question, p of 3 will be equal to g of 3. Got it? P of 3 is the remainder of the first polynomial. G of 3 is the remainder of the second polynomial, and in the question it is mentioned that both the polynomials leaves the same remainder. That means these two remainders are equal. So you can equate it. Okay. So we are equating. That means 3 cube minus p into 3 square plus 3 plus 6. That will be equal to 2 into 3 cube minus 3 square minus p plus 3 into 3 minus 6. P of 3 equal to g of 3. That means 3 cube is 27 minus 9p plus 3 plus 6 is 9. Right? Equal to 27 into 2. 54 minus 9 minus 3p minus 3 minus 6. Now what to do? Now you will take the constant terms to one side and the variable terms to other side. So 27 plus 9, 36 minus 9p plus 36. equal to minus 3p 54 minus 18. 9 minus 9 minus 9 minus 18. So plus 54 minus 18. Right? So we are taking the constant terms here. Taking the constant terms here means minus 9p plus 3p is equal to, it is minus 3p comes here plus 3p. 54 minus 18 minus 36. Comes as 0. Question is written correctly only, no? See there, 2x cube minus px square plus x plus 6. Then the second question, 2x cube minus x square minus p plus 3 into x minus 6 leaves the same remainder, then find the value of p. So you will take the value of p by taking p of 3. Sorry, p of 3, yeah, p of 3 means p is here. So 3 cube 27 minus 9p plus 3 plus 6 plus 9. 27 into 2, 54 minus 9 minus 3p, 3 3s are 9. Sorry, this is the mistake done. Sorry, 3 3s are 9 minus 6, otherwise it comes as 0, no? So here we will get minus 18 minus 6. So 54 minus 24. Right? So 54 minus 24, you can take it directly. What will you get? 0, 30. 30 and this 36 comes over there, minus 36. Clear? Here this was a mistake I have done. 3 3s are not multiplied. Here this bracket opening means minus p into 3, minus 3p, and minus 3 into 3, minus 9 will come. Minus 9, minus 6, minus 15. Minus 15 minus 9, it will be minus 24. So 54 minus 24 comes as 30. Right? 30, then plus 36 comes over here, it will be minus 36. Now simplify. What will you get? Minus 9p plus 3p. What will you get? Minus 6p. 30 minus 36 minus 6. So what will you get the value of p? P will be equal to what? This is question number 7. Okay. When you have two polynomials and there is a term divided by given and both the polynomials are leaving the same remainder. Same remainder means after substituting the value of x, you will get the same remainder. It equates. P of 3 will be equal to G of 3 and there you can find the value of P by substituting the value. So you are getting the value of P as 1. Okay. So this question also you can note down there. So this is the application of remainder theorem. Application of remainder theorem. We have two theorems. One is remainder theorem. Remainder theorem indicates that when we are substituting the value of x, we will get a constant. And that constant will be the remainder. So without the actual division, you can find the value of the remainder. Now, similarly, if it is a factor, of course, you will get the remainder as 0. So that will be one of the factor of the polynomial, the given polynomial. So next we are going to see, as I have told you, I have written a question in previously in the first year. At first I have written a question and I have told you this polynomial, if it carries power 3, degree 3, it implies that the polynomial is having 3 factors. And by showing or by taking, we were getting one factor. Now, how can you find out the remaining factors? That's also very important to you. I think you have noted down this one. Noted down this one in your fair copy. Question number 7 it is. Now we are going to see one of the another theorem, that is the application of factor theorem. Application of factor theorem. How can you find out the application of factor theorem? Okay. Application of factor theorem I am going to explain here. Alright. So I think you are now happy that no need of using the division method. Without using the division method also you can find out the factor or remainder etc. without, but it is also needed. The division method is also needed for your solution to find out the remaining factors. That's what I am going to show you now. So here there is a question. Show that this is question number 12. Question number 12. Show that x minus 2 is a factor of x cube plus x square. So you have to show. That means f of x is given as x cube minus x square. X cube minus x cube plus x square minus 4x minus 4. X cube plus x square minus 4x minus 4, right? So you have to show that x minus 2 is a factor. Show that x minus 2 is a factor. Show that means, of course, the remainder. Show that. The question is show that. So while substituting the value of x, of course, you will get the answer, the remainder 0. Because our question is show that. So after showing, find the remaining factors or factorize completely. That is your question. After showing, factorize the solution. So show that x minus 2 is a factor. It implies that while substituting the value of x, you will get the remainder 0. There it is given x minus 2. X minus 2 given means x will be taking the value 2. So according to question, f of 2 will be 0. But don't write here because we are going to show it. So we will take out f of 2. F of 2 equal to. If you are getting it as 0, then only we can write it. F of 2 equal to 2 cube plus 2 square minus 4 into 2 minus 4. 2 cube plus 2 square minus 4 into 2 minus 4. So you are getting 8 plus 4 minus 8 minus 4. 8 plus 4 is 12. Minus 8 minus 4 minus 12. So you are getting this equal to 0. Right? We got the remainder 0. The remainder 0 comes means therefore x minus 2 is a factor of f of x. So we have shown it. F of x minus 2 is a factor of f of x. We have shown it. Now what to do? One more time we are having. Hence factorize the polynomial completely. Hence factorize the solution completely. So for that we need the division method again. So we are going to show it by factorizing completely means you have to use the division method there. That means you will write the polynomial once more. X cube plus x square minus 4x minus 4. This is your polynomial. And we got to one factor x minus 2. That means that while substituting the value of x minus 2, you will get the remainder 0. So we are going to divide it. Divide it means you need x square here. X cube minus 2x square. Then subtracting you will get 3x square minus 4x. So you need 3x square minus 6x Then you will get plus 2x minus 4. So here you need plus 2x minus 4. I think all of you, because you might have forgotten last year we were not having the polynomials as well as the division. Year before last only you had seen, in class 8 only you had seen the long division method. But no problem if you have forgotten. Once or twice if you practice, that's not a difficult term. Once or twice if you practice the same, you will get it. Okay, I think almost 80-90% students are familiar with the division of a polynomial by another polynomial. That is familiar. By chance if you have forgotten, no problem. Practice 2-3 times, it will be clear to you. So did you see, after division we got the remainder 0 and we are having a quotient there. What is the quotient? X square plus 3x plus 2. So that is a quadratic equation. X square plus 3x plus 2. So the quotient we are getting as x square plus 3x plus 2. So if you are factorizing it, what will you get? If you are factorizing it, x square plus 3x plus 2, that means you need sum as 3, product as 2. Numbers will be plus 2 plus 1. So you can split it, x square plus 2x plus 1x plus 2. That means x into x plus 2 plus 1 into x plus 2. So you will get here two more factors, x plus 2 and x plus 1. Right? Then after factorizing the quotient, your question is factorize completely. Factorize completely means you have to write the polynomial in the product form. Polynomial in the product form. Therefore, your polynomial f of x in the product form. What is our first factor? X minus 2. So, first factor x minus 2. Second factor x plus 2. And the third factor x plus 1. Factorize completely. This is the second topic of this chapter. Got it? That is application of factor theorem. Previously we had seen the application of remainder theorem. Remainder theorem means there are two applications. One is finding the unknown quantity and the second one is find the remainder. Finding the unknown quantity as well as finding the remainder. Both the cases you will substitute the value of x. Whatever the constant, find the unknown quantity means the remainder will give in the question, that you will substitute in the reminders please. Okay. And the second concept is application of factor theorem. Show that this is a factor. Show that these are the factors. So that one is a factor. Okay. Then one factor you have shown. With the one factor you divide the polynomial with the given factor. Then you will get a remainder 0. As well as quotient you are getting a quadratic form. This quadratic equation factorization already over. So you will factorize the quadratic equation. Then finally the given polynomial f of x, you will write it in the product form. Given polynomial f of x, you will write it in the product form. Clear? So I think up to here whatever I taught today, everything is clear to you. What all things I have taught you? What is the general form of the polynomial? Then we had seen the factor theorem as well as remainder theorem. Both are same only. Same only means if it is a factor, remainder will be 0. If it is not a factor, then remainder will be a constant. That's all you have to remember. Okay. Then application of remainder theorem. That means you can calculate the remainder without actual division. As well as if remainder is given, you can find the unknown quantity by substituting the value of x. Then, now we had seen the application of factor theorem. Show that this is a factor. That means while substituting the value of x, if you are getting the answer 0, then it is a factor of f of x. So show that means normally the remainder will be 0. Then we got the first factor. With the first factor, we divide the given polynomial. There you will get a quadratic equation, and the quadratic equation you will factorize again. You will get two more factors. As this polynomial is having degree 3, it implies that this polynomial is having 3 factors, and we got all the 3 factors. Then finally the polynomial you will write it in the product form, x minus 2 into x plus 2 into x plus 1. That is the product form of the polynomial. Okay. Now one more concept, that means suppose if no factors are given. Your question is factorize completely either by using the remainder theorem. Using the remainder theorem only most probably will give factorize completely. This is clear now? Factorize completely. So there also you will have a polynomial given, and your question is factorize the polynomial completely. Again I am taking one question. Question number 14, first part. Question number 14, first part. That is given x cube plus 2x square minus 5x minus 6. And there is no factor, no term, nothing given. It is given that factorize the polynomial completely as going through the degree. What is the degree of the polynomial given here? The degree of the polynomial is 2, 3. It means that this polynomial is having 3 factors. This polynomial is having 3 factors, and you have to find all these 3 factors. Nothing is given. Only given that to factorize completely. Then what to do? We will go for our trial error method. Trial error method means we will take the given polynomial f of x equal to x cube plus 2x square minus 5x minus 6. This is the polynomial given. So we named it as f of x. Then you will try it. We will substitute when x equal to 1. X equal to 1 we will substitute. That means you will check f of 1. F of 1 is 1 cube plus 2 into 1 square minus 5 into 1 minus 6. That means you are getting 1 cube is 1 plus 2 minus 5 minus 6. This is not equal to 0 because minus 11 plus 3 not equal to 0. Not possible. Then you will go for f of minus 1. F of minus 1. That means minus 1 cube plus 2 into minus 1 square minus 5 into minus 1 minus 6. What will you get? Minus 1 plus 2 plus 5 minus 6. Are you getting 0? 5 plus 2, 7. Minus 6 minus 1 minus 7. So you are getting here equal to 0. So if you are not getting in minus 1, then you will go for 2. Then minus 2. 3 minus 3. Within these 6 values, one of the factor will get with this question. Suppose with this type of questions. Okay. 6 values. 1 minus 1, 2 minus 2, 3 minus 3. Within that, you will get to one factor. Okay. So for that we will apply the trial error method, and till when it reaches 0, till that time you will substitute the value. Here f of minus 1 equal to 0 we got. F of minus 1 equal to 0. That means what will be one factor? X minus 1 or x plus 1? X plus 1. So x plus 1 is a factor of f of x. X plus 1 is a factor. So one factor we got. If we got the one factor, the remaining factors again going for the division method, then taking out the question, then factorizing it, we will get all the 3 factors. So one factor we got. What is the one factor we got? We got one factor as x plus 1. then you will substitute it here. X cube plus 2x square minus 5x minus 6, dividing it with the x plus 1. Okay, so x square, you will get the x cube plus x square. Subtracting, you are getting x square minus 5x plus x square plus x, you are getting minus 6x minus 6. So minus 6 will be here, minus 6x minus 6 will be the remainder, and you are getting the remainder as 0. So what is the quotient we got there? X square. Either you can take it as x square plus x minus 6, that is equal to x square plus 3x minus 2x minus 6. Sum is plus 1, product is minus 6 numbers. Then you will factorize it, you will get x into x plus 3 minus 2 into x plus 3. So you are getting the two factors, x plus 3 into x minus 2. Finally, you are getting your f of x as first factor is x plus 1, second factor is x plus 3, and the third factor is x minus 2. Factorize completely. So today's concept up to here, I think everything is clear. Application of factor theorem. Show that one factor given, you will substitute it, and then you will get the remainder as 0. Then you can write it as this one x plus 1 is a factor or whatever. This is one factor of f of x. To find out the remaining factors, you will go for your division method of polynomial. You will divide the polynomial, then you will get a quadratic equation if it is power 3. If it is power 3, then only you will get a quadratic. If it is power 2, you will get a linear equation. In that case, no need of going for further factorization. So you will go for the division method. Whatever the quotient comes, if it is a quadratic equation, again you have to factorize it, and there you will get two factors, and then final answer f of x, you will write it in the product form of all three factors, x plus 1 into x plus 3 into x minus 2. So these are the concepts for you today. Okay, we had seen polynomial, mainly factorization of polynomial we are dealing here. But before factorizing the polynomial, we have a small application, that is remainder theorem. Find the remainder without actual division as well as calculating the unknown quantity, that also without actual division if the remainder is given. Then we had seen the application of factor theorem, show that it is a factor, then factorize completely. Or the third case, if no factors are given, then also find the factors, factorize completely. That means we will go for our trial error method, and by using the trial error method we will get the first factor, and that factor, by using that factor we will divide the given polynomial, then we will go for the second and the third factor, and all these cases the final answer we will write it in the product form, because factorization, factors always we are writing it in the product form. Okay, now note down your homework questions. Homework questions note down. Question number 5, exercise 6. Exercise 6, homework. Question numbers 5. Question number 5. 7, second and third, because 7 first part I have done. Second and third part of 7th one. Then question number 8. Question number 8. then 11, question number 11, 15. 11 and 15. So these are the homeworks today. Children, if you didn't get the textbooks, if any of you didn't get the textbook, please ask your companions, your friends are there, those who have got the textbook, they will give you a screenshot of these questions. Okay, you are having in contact with your friends. Okay, so not easy to write long questions on the board, then you cannot dictate all the questions. So I am giving the question numbers. Exercise 6, question 5, 7, second and third part, 8, 11 and 15. 15 there are 4 questions. So all these 4 questions you have to do. 15 all part. 15 all part. So that's all for today. Okay. So up to now we were dealing with the polynomials. Once more I am reminding you, polynomials, there are 2 theorems, remainder theorem and factor theorem. We had seen the applications of remainder theorem as well as application of factor theorem. Show that it is a factor or no factors are given, then also we will be able to factorize the polynomials. So factorization of polynomials we had seen today, and go through the exercise questions. If you are in your free time, you can go through the remaining questions also. Make it thorough with the terms, and we will meet you in the next class. Bye.